Hey guys, so today we're going to look at ionic compounds involving polyatomic ions. So what is a polyatomic ion? It is actually made up of more than one ion. And the way that they come together, they actually act as a single unit. So we can treat it as a single unit. We can treat it as if it was a non-metal ion or a metal ion. So what happens is the ionic charge that we normally see on just a metal or a non-metal is actually shared over the whole polyatomic ion instead of being just over one atom. So we can treat it as a single unit. So to name a polyatomic ion, we just go ahead and name the metal first. Because most polyatomic ions act as non-metals. So we go ahead and name the metal first using the periodic table, and then we name the polyatomic ion second as we find it in the chart. And you have a chart on your periodic tables that I gave you that has a list of some of the common polyatomic ions. It tells you their name, their formula, and their ionic charge. So when we go ahead and write formulas later, you'll be able to reference that. So you can see some of the polyatomic ion names here: hydroxide, bicarbonate, nitrate, and carbonate. So let's do a few examples together. So let's name these compounds. So the first one here is NaOH. So if I look up my metal in my periodic table, Na is sodium, and then I look up that polyatomic ion, that OH, on the chart on my periodic table, and that is the hydroxide ion. So the name for this compound is sodium hydroxide. And then the second compound there, CaCO3, the metal is calcium. So if I looked up Ca on my periodic table, that's calcium. And then I look up the formula CO3 in my chart of polyatomic ions, and that is carbonate. So the name for this compound is calcium carbonate. Okay, so writing formulas for polyatomic ions is a little more involved than just writing the name, just like it was for our binary ionic compounds. So the way to recognize if a compound contains a polyatomic ion is if it ends in ate, ATE, or if we see hydroxide. Then we know that it contains a polyatomic ion. So to write the formula, we use the same rules that we do for binary ionic compounds. So we can use the crisscross rule. And the only difference is that we're treating the polyatomic ion as a single unit. So if there is more than one polyatomic atom needed in our formula, we have to use brackets around it to show that the little subscript goes over the whole ion, not just the last element in it. So to name it, we name the metal first, to write the formula, we put the metal first, the symbol, and write the ionic charge over it. We put the formula for the polyatomic ion second and write the ionic charge over it. Then we can use our crisscross rule so that we can get the subscripts that are needed, so the number of atoms of each, and we'll reduce it to lowest terms. We still follow the same rule where we don't write 1 as a subscript. Okay, so if I wanted to write the formula for these compounds then, I would look up the symbols. So sodium is Na, and it has a charge of +1. Hydroxide is OH. It has a charge of -1. So if I crisscross those charges, they each have a subscript of 1, and we never write 1 as a subscript, so the formula is NaOH. The other examples that are listed here, I'd like for you to see if you can try those, and we'll take them up in class next time. So thanks for listening, and I will see you.